So the discussion today we have planned is grade 12 first term FWC 2021 March, the latest paper. Fine. So basically most of the questions are from mechanics until rotational motion, I think. So let's get on with it. First of all, first question. Which is not as an SI unit? Which is not an SI unit? So out of these, the answer is first one, which is not an SI unit. They are not talking about fundamental SI unit. So the problem is kilogram should be simple K, simple G. So they are just testing whether you know how to distinguish between capital K and simple K, right? So careful, that's it. Meter, second, Kelvin, these three are fundamental SI units. Joule is SI unit, no problem, capital J. So they are asking for SI unit, they are not asking for fundamental. Therefore, the first one is wrong because it has capital K, it has to have simple K. Okay, done. Moving on to the second question. 4 students have written units of force as given below. Um, which of the above is the right form? Now, when you take force, definitely Newton is correct. There's no argument in that. Newton is correct. So D definitely has to be correct. Therefore, only first one can be eliminated. No? Right. And then after that, now this one is incorrect. This one is incorrect. The reason is there should be gap between different units. Now, kilogram should be written together because kilo is a prefix. So prefix and gram should be written together. And there must be small space and meter, then second minus 2. Because these three represent three different quantities: mass, length, time. So there should be a space just like this, just like this. This is okay. And this is okay because the division sign is there. You can see between kilogram and meter, there is a space, no problem. And then they have given what do you call that, slash like this and second square. That means it means it's divided. So that is also okay. Hence, B, C, D should be correct. Answer is fifth. Answer should be fifth. Right. Should not be a big problem, these questions. Let's move on. Right. And question number 2. We take question number 3. Question number 3 after that. When a wave propagates through a medium, its displacement is given by y equals a sine kt, where a is the amplitude and t refers to time. So y is the displacement, a is the amplitude, and t is the time. And t is time, a is amplitude, and we know amplitude is also a length. Amplitude is also length in O-level classes. You must have known, but amplitude is not a problem for us because we have sine kt. They are asking for the unit of kt. Now, sine kt, that is our focus. That should be our focus. Whenever you have sine and inside sine something theta or something like that, this theta is an angle. Therefore, theta should be dimensionless because it's an angle. The same way, kt should be dimensionless because it's inside sine. Therefore, k should have the dimensions of 1 over t, and that is going to be how much? 1 over capital T, sorry, dimensions of k, and that will give you dimensions of k is capital T minus 1, right? So out of these, which one will give the corresponding unit for that? Well, that will be 4, because we don't have s minus 1, and radian does not have dimension because radian is the angle. For angle, people, radians does not have dimension, and this is not very new to you. We have done these questions in our MCQs. Sorry, when we are learning unit and dimensions. And moreover, we know radians per second is the unit of angular velocity. And the dimensions of angular velocity is t minus 1. So they haven't given you s minus 1. Only radians per second is available. And that is the only unit which has s minus 1. And there also you can see there's a space deliberately left. Radian second, different units, a space is given. So for this question, the answer should be 4. For a man with mass of 2 times that of boy, it takes twice the time to climb a certain height. What is the ratio between the wasted power of man and boy? Right, now question number 4. There is a man who has a mass of 2m, and then there is a boy who has a mass of m. They are climbing, is it a certain height? A certain height, yeah. So they are climbing a certain height. Then once they reach a height, they are reaching the same height. So man is here, boys here. Even you might, I don't know, not now, maybe you will also feel the same. When you become older and older, it will be difficult for you to, climb and walk and everything, because it's especially climbing, because you have to climb with your body weight. When you're very little, we don't get tired much, right? We can run around, we can climb everything because our body weight is less. So we don't have to put a lot of our energy is not wasted much. But when you get older and older, your body weight increases. So it's difficult. I don't know whether boys have felt it. You will feel it when you do like push-ups and pull-ups. You really feel that. Okay. When you are young, your body is very light, so it's easy to work out. You can do a lot of reps when you do push-ups and pull-ups, but as you get older and older, when your body weight increases and increases, it's difficult. It gets more challenging. Right? For that, you need to strengthen your muscles and work harder. Right? For something like that. So here, the time taken by the man is twice. Time taken by the man is twice the time taken by the boy. Isn't it? Yeah. So sorry, t is equal to 0, and the boy takes, right. Fine. The question: what is the ratio between the wasted power of man and boy? So why is power wasted? Now, when you climb a height, you will definitely get tired, right? When you climb a height, you get tired. Why is that? Your body has to waste energy to increase the potential energy. Now, when the boy and man are climbing a height, that means their potential energies have increased. They don't just get the potential energy. Some energy has to be converted to potential energy. So the chemical energy inside their body, when they eat food, they produce this chemical energy, and that energy is only converted. So power consumed by man, how do you write power consumed by man? Power consumed by man, let's start with that. Power consumed by man will be equal to, I'll just put like this: change in gravitational potential energy divided by time taken. Okay, so change in gravitational potential energy of man is how much? Mass g h divided by time taken is 2t. Time taken is 2t. So the answer is mgh by t. This is the power consumed by man. And how about the power consumed by boy? Or power wasted by boy? Right? Power consumed by boy. Same equation, no change. I mean, if you want to find power, how do you find power? Work done over time, if not energy consumed over time, or energy change over time. So the energy change for both is gravitational potential energy divided by time. And for the boy, the gravitational potential energy is mgh directly. Mass is m, height is h, g. They are both climbing the same height. They both are climbing the same height. Right. So, and divide by t. Right. Now look at them. This is the power consumed by man, mgh by t. Power consumed by boys is also mgh by t. For both, it's equal. Therefore, the ratio has to be 1:1. Okay. Right. Mass of the man is twice, but he's taking twice the time. So both of them are spending same amount of what power. Answer is first. Right. That's it. And then moving on to the fifth question. It's about vectors, forces. Correct? In the diagram drawn according to scale, what is the sum of four vectors OA, OB, OC, and OD with point O as the origin? Right, good. Now, when you get a question like this, OD and OB are in, say, the same line. OA and OC are in different lines. So what I'm going to do is I'm going to do something like this. This is drawn to scale now, people. Let's extend this one a bit like this. So I'll draw another two more cages, actually. Two more cages, not just another cage, two more cages. Like, fine. Now what I'm going to do is I'm going to find the resultant of OA and OC. Now, how do you find the resultant of OA and OC? Let's draw it separately. You have OA, OC. What do? You have to complete that parallelogram. Na? So when you complete the parallelogram, guys, OA and OC, what will you be getting? You'll be getting this as your result. And that will be, this is OA, OC, and this is OB here. No, not OB, sorry. The resultant will be here. This is where an OB is. So when you complete the parallelogram, I'll do it here again. You see, you draw a parallel line to OC, first of all. And then you draw a parallel line to OA. Then you get the complete parallelogram. You have two forces, parallelogram is completed. The diagonal of that parallelogram will give you the result. Diagonal of the parallelogram will give you the result. So you can change this diagram to this. Wait a minute, see if you can understand. We have OD on the left hand side, no need to change that, right? And then instead of OA and OC, I can put what? Another OD on this side. Hope you can understand that. Look at the length, because based on the length. This is the center part. OD already exists. Don't know this length is too much. Okay. OD already exists. And this is another OD. Why is it OD? Because it's drawn to scale, na people. It should also have four, what do you call that? Boxes, no? The resultant should have four boxes. That's why I've drawn like this. So this is also another OD. O, and this OD, the magnitude will be OD. No? What is this actually, this line? Resultant of OA and OC. Resultant of OA and OC. The magnitude will be same. Oh, no. Sorry. It's bigger. It's bigger. It's bigger. Sorry. It's bigger. It's bigger, no? It's little bigger. Here it's 3 times. That's it. Okay. It's 3 times. Here it's 4 times. They are not equal. Sorry about that. They're not equal actually. This is longer. So let's not mark it as D. This is a little longer. It will have 4 cages. No? It will have 4. So let's get rid of these letters and let's mark the magnitude. Let's directly mark the magnitude. So this is OD. OD has a length of 3 boxes. No, 1, 2, 3. Therefore, I'll just take it as 3x. And this resultant of OA and OC has how many boxes? 1, 2, 3, 4. So it's like 4x. Okay. And there is one more. Who is there? OE is there. OE or OB. Sorry, OB. OB is there. Right. I'll draw OB here in another color with another color. Draw OB with another color. Right. OB is here like this. And what is the magnitude of OB now? 2x, isn't it? So this is OB. And this is the resultant of OA and OC. And who is this 3x? That is OD. Now you have 3 vectors in one line. 3 vectors in one line. You have 3 vectors in one line. So what will be the resultant, people? What will be the resultant? Resultant will be from point O towards right, there will be 3 boxes left. From O towards right, there will be 3 boxes. Hope you can agree with me on that. From O towards right, there will be 3 boxes. So it's like 3x, because 2x plus 4x is 6x to the left, and 6x to the right, 3x to the left. Resultant is 3x to the right. Therefore, 3 boxes must be considered. Then what is the answer, people? The answer should be 5th one, isn't it? Because OE represents 1 box. Okay, OE. This is X. I have taken this 1 box as X. Each box has. So OE represents 1 box. Therefore, the answer should be 3 boxes. 1, 2, 3 boxes. Then the answer should be like 5th. Okay, so the technique is, first of all, you need to find out the resultant of OA and OC using parallelogram theorem. It will have 1, 2, 3, 4 boxes. And then already existing vectors are there. OB 2 boxes, OD 3 boxes. So on towards right, we have a resultant of 6 boxes. Towards left, you have 3 boxes. Therefore, the final answer is 3x towards right. And x can be represented by OE, because OE represents 1 box. So the only possible answer is 5th one. Question number 6 is about velocity time graph. The figure shows the velocity time graph of 2 objects A and B drawn on the same axis. Which of the following graph best represents the displacement of 2 objects with time? So you have A and you have B. Okay, right. To avoid any confusions, what I'm going to do is I'm going to just draw over A in one color. Then B will be in black color, right? So this is A. Now talking about A, what is this part? What is the meaning of this part? The graph is going down from 0. The graph is going towards negative side, so that you can represent that as acceleration in negative direction or opposite direction. Acceleration in negative direction. Okay, right. And this part can be represented. The second part, what now from a value, from a certain value, the velocity reduces to 0, but in the negative side. Therefore, that is deceleration in the negative direction. Deceleration in the negative direction. So I will just draw the graph for A separately. Draw the graph A separately. We normally draw it like this, right? Acceleration in negative direction means the graph will be like this, and then the deceleration, this is the displacement of A, yeah? Right? Deceleration in negative direction means the graph will be like this. The graph ultimately has to go down. This is how the graph should be for the two parts. Graph has to go down like this. All right. And how many such graphs are there for A? There's only one answer, right? With A itself, you can figure it out, can you? Which one is the answer, guys? A. First one, isn't it? First one, no? First one should be the correct answer. Because look at this now. I'll draw A. Look at this, right? This is a blue color, and I need that shape. I need that shape for A, and only this answer gives us that shape for A. This is different for A. All the other answers are some other answers they have given. And talking about B, now B also I will distinguish with another color very quickly. We'll do it and analyze B's variation of velocity. This is B, the red color one I'm marking. Right. So talking about B, this part, what is this part, people? That is deceleration in the negative direction, opposite. It is starting at a certain velocity and the velocity is reducing to 0 in the negative direction. And this part now, from 0, the velocity is increasing, magnitude of velocity is increasing in the negative direction. So that is acceleration in the negative direction. So for B, if you draw the displacement time curve, initial part is deceleration. That means the graph should start steeper and become flatter, and then again become steeper. This is how the graph for B should come, right? And that is given by this. You can see here. Where does the displacement time graph start? That's okay. Up or down doesn't matter. As long as the shape is intact, then that should be your answer. So overall, we can safely say answer is first. Answer is first. Okay. So just analyze step by step, part by part. Fine. Question number 7 is the next one. Question number 7. Right. It's about traveling microscope, isn't it? The scale of traveling microscope is marked at 0.5 millimeter. I think what they mean by that is main scale division. One main scale division is 0.5 millimeter. 50 divisions of vernier scale division coincides with 49 0.5 millimeter divisions. So 50 divisions of vernier equal to 49 divisions of main scale. So 49 main scale division equals to 50 vernier scale divisions. So the difference between them is 1. For such cases, you can find out the least count very quickly. Least count is going to be how much? 1 main scale division divided by number of vernier scale division. You can use this equation. When are you able to use this equation? Only when the coinciding units, there's a difference of 1 between them. 49, 50, 9, 10, 24, 25. Likewise. Okay. So 1 main scale division is 0.5 millimeter divided by number of vernier scale divisions is 50. Therefore, the answer is 0.01 millimeter for least count. 0.01 millimeter for least count. Sorry. And I think you know that anyway for traveling microscope, usually that's the one, but safe to find that. There are some instances where this can be 0.05, 0.02, can't take chances. So make sure that you confirm it. Right. And then in order to obtain a reading of 6.78 millimeter. Now, if you want to get a reading of 6.78 millimeter, let's try to draw that and get the answer right. Fine. So I'm going to draw the main scale divisions on top and vernier scale divisions on bottom. Right. This is main scale. This is vernier scale. Now, main scale divisions 0.5. 0.5 millimeter is one main scale division. Therefore, you will have 6.78 means you will have 6 millimeter unit, right? And then you will have 6.5 millimeter unit. Because the least count is, sorry, 1 main scale division is 0.5 millimeter. So this is how the main scale will be. And the vernier scale 0, I'll draw in another color. It should be here. It should start here, correct? It should start here. And now when you write the reading, how do you write the reading, people? Reading is equal to 6.50 plus 28 into 0.01. That will only give us 6.78 millimeter. Hope you can agree with me on that. Because with 6.5, you need to add 0.28 to get this answer. Therefore, 28th vernier scale units should be coinciding with, we don't know who, one of the main scale units. So this is how the coinciding happens. So if the coinciding is happening like that, how will you write the reading? You will be writing the reading like this: 6.50 plus 28. This 28 comes here, 28 into 0.01. So the question is, which vernier scale division has to coincide with one division of main scale? That should be 28. Okay. I can't think of any other method to explain this. So hope you can understand this. This is how we take the reading. The people, we first of all search for the vernier scale 0, and then we look for the main scale which is right in front of that. Then you write that first, and then you write the rest of the parts by multiplying the vernier scale division coinciding with one of the main scales by the least count. So that. Fine. So that is fourth answer. All right. Good. Next, let's move on to question number 8. Question number 8 looks like it's a projectile motion, isn't it? Yes, projectile motion. So I might need some more space. Wait a minute. The following graphs show the variation of horizontal displacement and vertical displacement of an object which is thrown at an angle of theta from the horizontal with time. What can be the possible value of theta? I think they are talking about theta. There's a printing error here. They must have given theta. So let's add that in the question. Because answers are in angles. Theta. Okay. Right. So focusing on this question, people, it's a projectile path. So let's just draw the path like this randomly. And yeah, the projectile path is this. The ball is thrown at a certain initial velocity. It is not given, I think. Yeah, not given. And the angle is theta. Time is equal to 0. And this is for the whole motion. Therefore, you can see the whole motion ends in 2 seconds. Therefore, the object reaches here at 2 seconds. Right? And how long will it take for the object to reach the maximum height? How much is it? 1 second, isn't it? 1 second, half of this time. And we know here there is going to be the component of u, vertical component, that is u sine theta. And here it's going to be u cos theta. And here the vertical component is how much? 0. And here the horizontal component remains as u cos theta. When it reaches here also, it remains as u cos theta. Right. Now we need to find out the angle, but we have two unknowns. One is the initial velocity and one is the angle. For that only they have helped us with two diagrams. So what is the meaning of this 20, people? Sx means horizontal displacement. Horizontal displacement is xx. That means the horizontal component of displacement, this one. Correct? And that is how much? After 2 seconds, it is 20 meters. This is what they're saying. Okay, right. 20 meters. R, yeah, this is the range. R is 20 meters, horizontal displacement. This is how you interpret this displacement time graph. Okay, in 2 seconds, it has gone a horizontal, it has traveled a horizontal displacement of 20 meters. That is the graph say. This is it. And here, this is the vertical displacement, as you can see, vertical displacement, SY. Vertical displacement means from this level, how much has the object gone up? Right? So after 1 second, we know the object is going to reach the maximum height. That is this height. And how much is that according to the question? 5 meters. 5 meters. Okay. Right. So you should be able to mark these information in a diagram like this after analyzing these two displacement time graphs. Okay. Now we are going to find out theta. Easy. You first of all, let's apply the horizontally, let's apply S equal ut plus half at squared equation horizontally. From where to where? I'll mark these points A, B, C. From A to C directly. From A to C. Let's mark use this equation. Right. What is the horizontal displacement from A to C? It's 20. What is the horizontal initial velocity component? U cos theta. Time taken is 2 seconds. Plus half at squared is 0 people because the horizontal acceleration is 0. There is no horizontal acceleration. Vertical acceleration is 10. Gravity. But horizontal, they are not talking about any AR system, so there won't be any horizontal acceleration. Therefore, this 2 and this 20 can be cancelled out. You will be getting U cos theta equals 10. U cos theta equals 10. Right. And you know the vertical height, you know the initial velocity, you know the final velocity, you know the time. So what you can do is from A to B upwards, why don't we apply an easy equation like this? Let's say S equal U plus V over 2 into time, something like this. Yeah. For S, what will you put then? 5. From A to B, it's just 5, vertical displacement. Initial velocity, U sine theta. Final velocity 0 divided by 2 and into how long does it take for the object to reach the maximum height? 1. How do I know it's 1? Because for the total motion it's 2 seconds. Therefore, for the half of the motion it will take 1 second. So you can say U sine theta here 1 means it's just 1. Multiply, you will get this again. U sine theta plus 0 is U sine theta. This 2 goes up, becomes 10. U sine theta is also equal to 10. Okay, U sine theta is also equal to 10. U cos theta is also equal to 10. You can find it in another way also. How is that? If you wish from A to B, you can apply this equation as well. What is it? Upwards, V squared equal U squared plus 2AS. And for V squared, what will you put then? 0. For U squared, what can you put? U sine theta squared plus 2 into, for acceleration, minus 10. Why minus 10? Because we are applying the equation upwards, gravity is acting downwards, gravitation acceleration is downwards. Into displacement in the vertical direction is 5. 5. So when you multiply, this is minus 100 goes to the other side. 100 will be equal to U sine theta squared. One more time, once again, U sine theta is again, it's 10 when you take square roots. So I don't know, either method works. Either method works and you will still end up in the same value. Right, okay people, you have the answer. Now to get theta, what do you need to do? You need to get rid of U. So to get rid of U, you can divide 1 by 2. When you divide 1 by 2, what will you be getting? U sine theta divided by cos theta. U sine theta divided by U cos theta, and that is equal to 10 over 10. What do you have on the left side? Tan theta. What do you have on the right side? 1. Well, how did I get tan theta? U cancels out. Sine theta divided by cos theta is tan theta. And 1 can be written as tan 45. That means theta is equal to 45 degrees. Hence the answer is third, isn't it? Third. Question number 9. What does it say? An object is at equilibrium under the exertion of 3 forces on a single plane always. When moment of force is calculated from any, object is at equilibrium, guys. The object is at equilibrium. So what is the condition for an object to be at equilibrium? There are 2 main conditions. One is resultant force should be 0. Second one is resultant moment about any point should be 0. These are 2 main conditions which must be satisfied for an object to be in equilibrium, at equilibrium. All right. When moment of force is calculated from any point on the plane, the algebraic sum is 0. Yeah, that's correct. No, that's correct. The line of action of forces meet at one point. That is not true. The reason is they have not mentioned that the forces are parallel, isn't it? Now imagine a situation like this. Imagine there's a rod, right? There's a rod hanging, and you have connected 2 strings like this. 2 strings like this, and the weight of the rod will be acting downwards. It's 40 Newton. And string here, in one string the tension is 20 Newton. In the other string the tension is 20 Newton. 3 forces are acting. The object is at equilibrium. No problem whatsoever. But are these forces meeting? They are never going to meet. Okay, so it's not necessary for line of action of forces to meet if the forces are parallel. But if they are not parallel, yes, for an object to be at equilibrium, they should meet. If they are not parallel. But if they are parallel, They don't have to meet. And in this question, they have not specified that the forces are parallel. Therefore, B is wrong. If B is wrong, second and fifth can't be the answer. Okay, right. Resultant force is zero. Obviously, yes. That is one of the main requirements. So C is correct. If C is correct, one is also wrong. So it's either third or fourth. The resultant force of any two forces is equal to the magnitude of third force. Correct, no people? We have done this many times. Now, if you take the resultant of T1 and T2, if you take the resultant of T1 and T2, it will be how much? 40 upwards. Something like this. We have learned, right? Now, if you take a random object like this, when there are three unparalleled forces acting like this, and the object is at equilibrium, let's say this is F1, this is F2, this is F3. And when you take resultant of F1 and F2, that will be equal to who? That will be equal to F3 in magnitude, but opposite in direction. Direction is opposite. That's okay. But the magnitude is same. They're saying magnitude. So that is okay. This F3 means resultant of F1 and F2. Well, that means D is also correct. So the answer must be fourth, people. Question number 10. An object made to move along a rough path with a constant speed v from P to T. Which of the following graph shows the variation of dynamic frictional force with moving distance? Throughout the pathway, coefficient of friction between the object and the pathway remains the same. Okay, fine. Now this is a rough plane, people. This is a rough plane. Okay, it's a rough plane. And the object is moving at a constant velocity. Very, very important. Read carefully. An object is made to move along a rough path with a constant velocity. Constant speed, sorry, constant speed. That means the magnitude of velocity speed can't change. That means the resultant force acting on the object must be zero. So here there will be a force acting on the object. We are applying a force, some applied force, and the frictional force will be acting on the object, the dynamic frictional force. And now the dynamic frictional force here at this point, it's equal to what, people? That is equal to FD, FF, the force which is applied to the object. That the object can't go without a force being applied to it. For example, it can be a vehicle. So the engine should be giving the force in the forward direction, things like that. Okay, without an application of force, the object can't move at constant velocity on a rough surface. So continuously there will be a force acting on the object. Now, when the object is here, what is the problem? The object is here. Let's mark the forces in another color, blue color. I'll use blue color. So the force you are applying is continuously acting in the forward direction. And the friction is now acting downwards, FD. But there is the influence of another force. What is that, people? That is the, this is FD. Okay, FD. And then we will have mg sine theta as well. Now here, we'll have mg sine theta. Mg sine 60 actually. In the opposing direction. Okay, right. So they are the blue color part. For the blue color part, if you consider the resultant forces, F is equal to what? FD plus mg sine theta. And that will give you FD equal F minus mg sine theta. So the red color part is from P to D. FD is equal to F. Blue color part is from Q to R. FD is equal to F minus mg. So there's a small reduction in what do you call that? Dynamic friction. Reason is weight is also going to oppose. So dynamic friction will reduce a little bit. And let's go to RS part. What will happen at RS part, people know? And the object is at RS part. Now, the force, I'll use green color, right? The force will be applied in the forward direction, F, and mg sine theta will also act in the same direction, isn't it? And the frictional force will be opposing the motion, it will be acting opposite. And now, for this case, FD is equal to F plus mg sine theta, correct? FD is equal to F plus mg sine theta. Right. That's how it's going to be. So when you compare it that way, what do you think would be the best? And again, one more time, the object will be coming to ST part, and again it will be the same. It will be same as the red color part. Now, people, there'll be a force acting, and there'll be dynamic frictional force acting, and the applied force is going to be equal to dynamic frictional force. So from P to Q and S to T, it's identical. From P to Q and S to T, it's identical. Everywhere it's same. Everywhere it's same. Now in between, when you go from Q to R, there must be a reduction in dynamic frictional force when you go from Q to R. And when you go from R to S, there must be an increase in frictional force. So when you compare the graphs, the best option looks like the third one, isn't it, people? Because look at this. From P to Q, there's a value. Suddenly, there's a drop when you go from Q to R. It should be like that because it's F minus mg sine theta. And when you go to when you go to RS, there must be an increase in frictional force. So there's an increase, a drop and an increase. Only in the third answer you have such variation. Only the third answer you have such variation. No, first one is wrong. First one is increasing, not that. It has to be constant. The force has to be constant. Friction has to be constant. It means friction is increasing uniformly. It can't happen that way. If friction increases this way, then yeah, there can be problems. You can't. I don't think that is correct. I mean, it says the friction is greater than the initial force. Because here, look at this. It's F minus mg sine theta. So from Q to R, it should be lower than the initial value, definitely. So first one is definitely not the answer. Right. So based on this, you can decide. Based on this, you can decide first one is not the answer. And fifth is wrong. So the best option out of the answers given, people, is the third one. Okay, is the third one when you analyze it like this. And the object is moving at constant velocity. That's why I'm equating all the forces. Not constant velocity, constant speed. Why are they using the word constant speed? Because the direction is changing. Like this. So, but the magnitude of speed is not changing, means resultant velocity must be zero. So that's why we are, equating the forces like this. Answer is that. Question number 11. From vertices A and B and C of an equilateral triangle ABC, three equal mass objects move along the median with constant speed V and collide at point O. Right, you can see three masses are moving towards point O. They are colliding. They are colliding here. So just before collision, this is how the masses are going to look like. Just before collision. And they have named the particles as well, A, B, and C. Right? This is just before collision. Now, just before collision, guys, what is the resultant momentum? What is resultant momentum? Resultant momentum is zero. Initial resultant momentum is zero. Why is that? We have learned now when there are three vectors. Now there are three vectors. 1, 2, 3 vectors. I'll draw them. See, there's a vector like this MV, and there's a vector like this MV, and there's another vector like this MV. And what is the angle between them? 120. We have studied now under forces when there are three forces acting this way. Equal magnitude. That's very important. Three forces of equal magnitude, when they act 120 degrees between them, the resultant will be what? Zero. Same thing is happening here. Three objects are moving, so their momenta will be like this. A will be momentum. A will have a momentum downwards. B will be having momentum this way. C will be having momentum this way. So it will look like this. Therefore, the resultant initial resultant momentum is zero. Keep that in mind. This is just before collision. That is where you have stopped. And then A comes to rest. Now let's focus on the other part. After collision. Just after collision. Just after collision. A comes to rest. Okay, A velocity is zero. Right. B travels back along the same path with speed V. B, it is going to travel this way. B, and it has a mass of m. Remember, velocity V. So anyone tell me the angle? This angle. What is this angle? People, this should be definitely median. This is 30 and 30, now, because it should be bisecting the angle. It's an equilateral triangle, so the angle is 60. Bisected means 30. So this is also 30, alternate angle. So B will be traveling this way, 30. Hence, what is the direct speed and direction of C after collision? Right. This is A after collision. This is B after collision. Then what about C, people? All right, draw in a different color. C should travel at opposite direction, same velocity at the same angle. Do you agree with me on that? This is C. This is how C should be traveling. Why? Because total final momentum, final resultant momentum must be what? 0. It must be 0 because the initial total resultant momentum is 0 now. So the final total resultant momentum also will be 0, should be 0 because A is already at rest. So it does not have any momentum. B is moving towards OB direction. That means C should move in the opposite direction to balance that out. So it should be moving along which direction? At a speed of V, BO direction. BO, away from OB. Speed of V. So C should travel at a speed of V away from OB. But I don't think that answer is there in this question. That answer is missing, I think. Let's see. V. So V by 2 are wrong. Final velocity must be V. Root 3 V also wrong. V along OB is wrong. V away from OA is also wrong. It should have been V away from OB. Therefore, all the answers are wrong. So in the scheme, they had given all as the answer. So you'll get a free marks for this question. Okay, none of them is the answer. And if you want to know what is the correct answer, this is the correct answer. I have marked it here. Right? Question number 12. An object is thrown downwards vertically with the initial velocity of 10 meters per second. Okay. So it has an initial velocity now, not dropped. When time is equal to 0. Right. From a point at certain height. Okay. If the distance that the object fell is equal the last moving second and the initial moving 3 seconds. Look at the translation, right? That what they mean is the distance moved by the object during the first 3 seconds and distance moved by the object during the final second of the motion are equal. Right? So something like this. So when the object reaches here, it is time equal 3 seconds. And this is time, if you take this as time equal capital, if you take this as time equal capital T, the final time, what is this time then? It should be time equal capital T minus 1. Okay. So what they have mentioned is this distance. I'll mark it as S1 and this distance S2. Or else, yeah, these two distance, I'll say D1 and D2, something like that. Okay, D1 and D2, they are equal. Okay, so your target is going to be equating them. That's it. Your target is going to be equating them. So to find D2, you can do this. You can find the whole distance, total distance fallen by the object during time T. And then you can subtract that from the distance traveled by the object when time is T minus 1, like this. Okay, so let's mark the distances now. This distance I'll mark it as ST, the distance traveled during time T, and this is ST minus 1, right? Fine. So first of all, let's mark D1. Let's find out D1 quickly. D1 is equal to, okay, how do you find D1? You can apply S equal UT plus half AT squared, okay, from here to here. So that will be when time is equal to 0 to time is equal to 3 seconds. You can directly you apply it. So this displacement from here to here is D1. Initial velocity is 10. Time taken is 3 plus half into acceleration is 10 because it's gravity into d square is 3 square. Therefore, d1 is going to be equal to 30 plus 45, that is 75 meters. So d2 is also equal to 75 meters. In the question they are saying d1 is equal to d2. Okay, so d2 is equal to 75 meters. Right, fine. And then let's apply the equation from t equal to 0 to t equal capital T. And let's apply equal s equal ut plus half at square. S is st, u is 10 capital T plus half into 10 capital T squared. So that will be st equal 10t plus 5t squared. First equation. Or else I'll just leave it as it is. And then I'm going to apply the equation from time equal to 0 to time equal capital T minus 1. Okay, right. For that, when you apply the equation downwards, all these equations are applied downwards because the object is moving downwards. S equal ut plus half at squared. Now, what is S there? From here to here, that is S t minus 1. Initial velocity is 10 into t minus 1 is the time plus half into 10 into t minus 1 squared. Right. St minus 1 is equal to 10t minus 10 plus 5 into t minus 1 squared. So what is t minus 1 squared? T squared minus 2t plus 1. If you expand the bracket, I think it will get easier for you. So st minus 1, that is equal to 10t minus 10 plus 5t squared minus 10t plus 5. Oof. Okay, no need to panic. See, 10t and 10t, it's getting cancelled off, isn't it? 10t and 10t is getting cancelled off. And we will get st minus 1 actually equal to 5t squared minus 5. How did minus 5 come? Minus 10 plus 5. This. And 10t minus 10t will get cancelled off. Simple as that. Right. Hope you guys understood it. Just small maths. And now d2. d2 is our concern. The distance traveled during the final second. That is d2. Distance traveled during final second. Right. So d2 we know it's equal to st minus 1. The total length should be, from that you subtract the other length. So d2 is 75. We already have found it. St is this one, 10t minus 5t squared minus st1 is 5t squared minus 5. So 75 is equal to 10t minus 5t squared minus 5t squared plus 5. That's it. So the answer is 75 equal to 15. Sorry, 15. No, what? No, not 70. So 75 is equal to 10t plus 5. So 5 goes the other side, it becomes 70 equal 10t. Hence, t is equal to 7 seconds. The time, then what is the time taken by the object to fall down? That is t. What is capital T? You have found capital T and we have found it. It is 7 seconds. Answer is 4th. Sorry guys, for ST it should have been 10t plus 5t squared. Plus 5t squared. Beg your pardon. Here ST was 10t plus 5t squared. So I should have substituted 10t plus 5t squared. Sorry. So 5 plus 5t squared and minus 5t squared will get cancelled. Sorry. Question number 13. It's about F equal MA probably. Elaboration means tension. It's tension. As shown in the figure, 4 blocks with different masses are joined to each other with string of negligible mass. So these are light strings. They are kept on a smooth surface and pulled with the horizontal force of 240 Newton. If the tension on string that connects blocks B and C, this string is 100 Newton, then what is the mass of block B? Okay. So since the object is connected to inextensible strings, they have not mentioned it's elastic string. So we have to assume that it's inelastic. All these objects will be traveling at the same acceleration. Okay, right. So what can you do? First and foremost, you can find the final equation for acceleration for the whole system. Let's apply F equals m for the whole system. Right. So what is the resultant force for the whole system? 240. Sorry. Because for B and D, there will be T1, T1, T2, T2, T3, T3. When you take the whole system, those tensions, they will get cancelled out. So only this one will be remaining. And for mass, what should I put? 13 plus m plus 15 plus 20. The whole thing. 1, 2, 3, 4. And A. A is the total acceleration. Therefore, we'll be getting an equation 240 equals 13 plus 15 is 28. 28 plus 28 plus 20 is 48 plus m. 48 plus m into A. I'll take it as equation 1. There are two unknowns, m and a. So I need two equations. With one equation, I can solve this. And then they have mentioned that the tension acting on BC is 100. So if they have given you a tension like that, what you can do is this. Now, they have given us the tension acting on string BC. What you can do is when you get questions like that is you separate that whole portion like this. This is what I do, which is very convenient. You separate them and take them both together as one system. So there is a tension here now. What is the tension? 100 Newton. The 100 Newton is applied for B and A. And they both will be moving at the same acceleration, isn't it? Because the whole system is moving at the same acceleration. Methane to break this system here and consider it with two masses now. And the acceleration we have, and the masses, this is 13 kilogram, and the mass of B is unknown. Right. Now for this system only with A and B, which is experiencing 100 Newton tension, apply F equal ma once again. Earlier I applied for all four masses together. Now I'm applying for A and B separately. So for the system now, again, the resultant force is going to be 100 because there will be tension here, T1, T1. It will get cancelled off when you take resultant. And mass is now 13 plus m into acceleration is still A. The whole system will be moving at the same acceleration. You have equation number 2. Our target is finding mass of a block B, which is m. We have taken it as m. Right. So I need to get rid of simple A. What is the only thing I have to do? Let's divide the first one by second one. The equation. 240 divided by 100 is people. You can divide both by 20. Na? 12 by 5, isn't it? Not okay. Never mind. To reduce confusions, I'll write the whole thing. 240 divided by 100 equal to on the right hand side, you are going to have 48 plus m into A divided by 13 plus m into A. Right. So when you simplify stuff, here you will have 12 over 5. You can divide both by 20. A and A will get cancelled off for 48 plus m, 13 plus m. And then what can we do? Let's do the cross multiplication thing. 12 plus 13, that is 156. 12m plus 12m equals 12 into 13 actually. 5 into 48, 240 plus 5. And then 7m equals 240 minus 156 is 84, isn't it? 84, nah? Yeah, 84. So m is equal to 84 by 7, that is 12 kilogram. I'm not using calculator now. When you want to multiply 12 and 13, I know 12 into 12 is 144. I need to add another 12 to make it 13. So 156. 48 into 5 is 5 into 40 is 200. 8 into 5 is 40, 240, like that. Answer is 12. Second one for 13th. Normally what they do is they give all the masses and they will ask you to find the tension somewhere in between. This time they have given the tension in between. They are asking to find the mass. Same steps, same steps. Question number 14. Two spheres of equal mass 2m are made to undergo completely elastic collision when moving towards each other with same speed v. Right. Just before collision, 2m is the mass. They are traveling at v towards each other. Now, after collision, what do you think will happen? After collision, what do you think will happen? most probably they are going to move like this. 2m is going to move in the opposite direction. This 2m is going to move in the opposite direction like this. The momenta will be just transferred. That's it. They are equal mass. So it is completely elastic. Elastic collision means what shouldn't change? The total kinetic energy can't change. So initial total kinetic energy, how much is that? That is going to be 2 times, both will have same kinetic energy, half into mass into v square, correct? So this 2.5 will get cancelled off. Finally, you'll be getting 2mv square. So total kinetic energy after collision should also be the same. Why is that? Because it's elastic collision. So total initial kinetic energy and total final kinetic energy must be same. There mustn't be any energy loss. Okay. Then the second one is the answer. Second one is the answer. Right. Now let's see why other answers are wrong. Both spheres come to rest. It's wrong because if both the spheres come to rest, the final kinetic energy will be zero. That can't happen. Initially, there's a kinetic energy. Since it's completely elastic collision, after collision also same kinetic energy should be there in the system. Total kinetic energy is less than 2mv square. That is wrong. It is elastic. Kinetic energy can't reduce. Total momentum is 4mv. Completely wrong. What is the total momentum, people? Can anyone tell me the total momentum? Total momentum, how much is that? Total momentum will be equal to momentum of this is 2mv in this direction plus momentum of the other one is 2mv in this direction. So resultant one will be 2mv minus 2mv, 0. Resultant total momentum is 0 because both are traveling at opposite directions with equal momentum. Therefore, that's why this is wrong. Total kinetic energy is 0. It is this. So answer second. When you see the word complete elastic, total kinetic energy should be same before and after collision. That's the concept. 3 masses M1, M2 and M3 start moving from point O at same time from rest along 3 smooth pathways OA, OB and OC. So there is no friction. And finally reach points A, B and C on the same horizontal level. Okay. The time taken to reach the horizontal level by M1, M2 and M3 are T1, T2, T3 respectively. All right. Now the problem there is times will be equal if these paths, the length of these paths are equal, OA, OB and OC. The issue is, are these paths equal in length? That is the question mark I have. Let's see. And the speed when they reach the horizontal level is V1, V2, V3. So when these objects reach the bottom, now when A reaches the bottom, it has a velocity of V1 or speed of V1. When B reaches the bottom, it has a speed of V2. When C reaches the bottom, it has a speed of V3. All of them, when they were at the top, what were the initial speeds? 0. All 3 of them. Okay, right. And then they have given us 3 what do you call that, 3 statements. We have to find out which ones are correct. Now statement A, first of all, before that, let me analyze something. For all A, B, C, something is common. What is that? They all start from the same height, people. They all start from the same height, right? So you, for all 3 of them, you can use this equation. Final kinetic energy, that is equal to initial gravitational potential energy. Initial gravitational potential energy. We can take this as our 0 potential level. So when they reach the horizontal level, bottom level, their potential energies will be 0. Final kinetic energy is half mv squared. I'll use m as the common symbol. V also has a common symbol. Initial gravitational potential energy is mgh. Therefore, v square is equal to m and m cancels off, no people? M and M cancels off, 2 goes up, it becomes 2gh. Therefore, V will be equal to square root of 2gh. For all A, B and C, height is same, no people? Height is same, and the velocity when they reach the bottom, it does not depend on the mass. Okay, so the conclusion is V1 equal to V2 equal to V3. All 3 are equal. Okay, all 3 equal. So all reach the same speed. That is correct. Hope you all understood that. You can decide this based on energy principle. So if if B is correct, this is wrong. This is wrong. Yeah, 2, 3, 4 possible. 2, 3, and 4 are possible. Okay, right. Then moving on. Now, then they all are reaching the bottom at the same speed. No, they have the same speed, v. The speeds are same. Now we have to decide the time taken. Now the time taken. Now they start here time equal to 0, and they reach, each of them reach at different times. Now t1, here t2, here t3. So to decide how long are they going to take, we need these distances, guys. We need to decide based on this horizontal, this distance of OA path, OB path, and OC path. The issue is who is longer here. That's the problem. Now, if this is a mountain or like something like that, when you take photo from here, OB path will look shorter than its actual length. No? So we can't, from this diagram, you can't say who is the longest. They should have given us an idea about OA, OB, OC. I can remember a question like seeing a question like this in one of the Royal College papers. In that they had given the lengths, which length is longer or something like that, but here they haven't given. So you can't decide the time. If, for example, if OC is the longest distance, they all reach the bottom at the same speed. No? So it's like they all are walking down. So if it is the longest distance, it will take the longest time. Okay, so A, there is a question mark, people. Since we don't know about OA, OB, and OC, I'll leave it there. Let's try to check whether we can decide about C. C, they are saying M1 V1 squared equal M2 V2 squared. What do you think about that? Right, now, if you apply the energy concept for different objects, now M1, M2 are masses of A and B, right? A, B masses M1 and M2, right? So if you apply for A, when you apply the energy equation, you can say what? Final kinetic energy, that is equal to initial potential energy. So final kinetic energy is half m1 v squared equals equals m1 gh. That's an equation, and if you apply that for B, you will be getting half. Okay, v1 squared kilogram common. M2 v2 squared equals m2 gh. So what can you say about these things? Now these two are equal. These v1 and v2 are equal. Okay, no problem. They are starting at the same height, but that doesn't mean that their masses are equal. We can't directly say that their masses are equal, no, people, because they reach the bottom at the same speed. It does not depend on mass. So if the initial potential energy of A is m1 gh, final kinetic energy of A is half mv square. Okay, so we can't say that their energies will be equal. I mean, individually their energies will be equal. Their speeds will be equal. True. Now they both start at this point, and they both reach the bottom at speed v. No problem. But that doesn't give us a clear indication that their masses are equal. No. Now this can be 2 kilogram. This could be 2 kilogram. This could be 3 kilogram. 3 kilogram. By velocity does not depend on mass. So I don't think C is correct, because we can't say that mass is equal, and we can't say that the potential energies are also equal, because they are starting from the same height, but their masses, they are not, we don't know whether they're equal or not. No. So I think C is wrong. C is wrong means what is the only possible answer we have? A, we can't surely say. No? So it's either second or third. In the scheme, they have given second as the answer. So definitely this is wrong. Okay, no problem. Fourth is wrong because you can't say this. Now we know V1 is equal to V2. That is okay, 100% sure. No problem, this one. But there is no clear evidence to show that M2 is equal to M1. So no, this is wrong. Can't be correct. So it's either second or third. It's either second or third. So since A cannot be clearly obtain A, because they have mentioned about OA, OB, OC. If you have marked second or third, the answer will be accepted. Okay, 2 or 3 in my opinion. 2 or 3 is fine. Question number 16. A circular disc of 10-meter radius is at rest. So it has a radius of 10 meters. Okay. This has to be raised to a stage of height 2 meters. All right. The mass of disc is 9 kilogram, and the part at which the disc touches the stage is rough. Okay, this part. What is the minimum force F in order to raise the disc to the stage? So if you want to, they're asking for the minimum force. That means now when you give us very small force, the disc will not go up. But when you have given sufficient force, the contact between the disc and the surface will disappear. No? That means that is the point where this R becomes 0. When your F is minimum, remember that. When your F is the minimum required value, your R becomes, R means the perpendicular reaction between the disc and ground. No? So when R is 0, that means the contact is disappearing. We have learned whenever there's a contact between two surfaces, R will be there. But now the contact is disappearing, so R won't be there. And exactly at the center, who will be there? The weight will be acting, that is 90 Newton. And from this point now, we need to know the lengths, isn't it? Now the radius is given to us. Radius is 10 meters. So I will mark this length as 10 because it's a radius, isn't it? 10 meters. Right. And what about this length then? Now I need to take moment from here, this point, moment from X. Moment from X must be taken. Careful. So wait. X, I'll mark it. This is point X, I'll mark it here. Right. And I need this from X to take moment about F. I need this length. So can someone tell me what is this length? What is this length, people? What is this length? What is the length I have marked right now? That is going to be no. This small length. Ah, yeah, correct. Thank you. 8 meters. Exactly. Diagram is not drawn proportionally. Yeah. The total length will be 10 meters. This total length will be 10 meters because it is also radius. From that, when you subtract this 2 meters, it will be 8. Okay. So when you want to take moment about X, we don't know the force acting at X, so take moment about X. There will be a moment due to force F, and the distance to force F, the perpendicular distance to force F will be 8 plus 10, that is 18 meters. This is the total length. It will be 18 meters. That's first. And the second length you will need is the length to the weight. That is this length, people. X. Okay. How do you find that length now? That length is now, this is X and this is the radius, correct? This is the radius. So it is 10 meters. And what is this small length, people? What is this small length I have marked here? What is this small length? That is 8 meters, isn't it? That is 8 meters. So if you take that triangle separately, right, this is 10 meters, this is 8 meters, and this is X. So can someone tell me what is X? Using Pythagoras theorem, you can find out it is 6 meters. 10 square is 100, 8 square is 64, 10 minus 64 is 36, square root of 36 is X. Okay, using Pythagoras theorem, you can find X. So this is 6 meters. Right. So when the disk is about to be lifted off the surface, there are going to be two different moments from about point X. So one is the clockwise movement and the other one is the anti-clockwise movement. So the clockwise movement about point X is going to be F multiplied by 18. X from X, the perpendicular distance to F is 10 plus this small distance 8. How did I find this as 8? This total length is the radius 10 meters, the height of the wall is 2 meters. So 10 plus 2 is 8. Equal to the moment created due to weight is anti-clockwise, no? So that should be 90 multiplied by this distance X, and that X we just found out, it is 6. So F will be equal to, now when you simplify this, 18 and 90 you can simplify and put a 5 now here, people, 5. So 5 into 6 is, people, final answer 30 Newton. That is how you have to do it. Okay, it's basically a moment question, and this R has to be 0 because when F is minimum, I'll just make a note of that also. When F is minimum, disk is at the verge of losing contact with the surface. The flow or whatever it is. Yeah, okay. All right. Answer is 30 Newton. Sorry, I have not marked it. So it should be the third answer. Question number 17. A vehicle that moves along a horizontal path with constant velocity V0 is tied front and back with ropes to walls which are pulled horizontal by humans A and B respectively. If the tensions in the ropes are T1 and T2 respectively, which of the following is correct? Okay, now vehicle is moving at constant velocity, guys. Vehicle is moving at constant velocity. There's a question like this exactly in the past papers, correct? So if it is moving at constant velocity, what is the conclusion we can make from that? Resultant force is 0. So resultant force 0. Resultant force is equal to 0. Okay, and so the vehicle doesn't have any acceleration. So the people inside the vehicle, this person and this person, they also should have 0 acceleration. Therefore, the resultant force acting on them must be 0. So how is it 0? He will be pulling the, what do you call that? Pulling the vehicle with T2. And now when you want to pull something like that, you have to press the flow with your feet and only pull, na people. Try pulling something, connect a rope to a cupboard or something and try pulling it. You can't do it just with your hand. You have to push the flow with your leg as well. So you will be pushing the flow, how? In the, so there will be a friction acting on your flow in this direction, in this direction, to balance this T2. No, sorry. It will be acting in the opposite direction. Sorry. Because when the person is pulling the rope to the right, rope will pull the person to the left. So on the person's hand, a force will be acting towards left side. So friction will be acting in this direction to balance the force. So this friction will be equal to this F2 will be equal to D2. Hope you can understand. Because when you want to pull this rope, what will you do? You will push the flow. What do you call that? In this direction, no? Try pulling it. You can do it now. We like press it and see. Sit it on the table, right? So you are pushing the earth this way, no? So earth will be pushing it this way, right? So the resultant force acting on this will be 0. If you're wondering how the resultant force is 0, this is how it's 0. And here also same thing. If there is no friction, what will happen to this person? He will slip and fall. He can't do this. He can't pull this without friction. He'll slip and fall. He'll be in the ground. He won't be like this. And here the friction will be acting in this direction, opposite direction for tension, F1, and that is equal to T1. So the answer for this question is, people, this 0. Okay. Okay, fourth and fifth. Wait. Relative to vehicle, work done on both the humans is 0. Relative to earth, work done on, wait, sorry, wait. Work done on humans by the tension of force relative to earth is 0. No, sorry, right. Now, work done on humans by the tension of force. By the tension means there is a tension acting on the person and the object is moving a certain distance. No? Resultant work done means now the resultant force is acting on 0. Net work is 0. Net work will be 0. You can say something like that. Net work. Because due to tension there is a work done, and that work done is opposed by what? Friction as well. So I made a mistake one more time here as well. Sorry. The friction will be acting on the man in this direction. Sorry, yeah. Why? Because he will be pulling the rope to the left. Rope will be pulling him to the right. So to balance that, friction will be acting on his feet like this. So if you take a single man, this man, there are two forces acting on him. One is T2. I should have drawn like this, then it will be less confusing. F2. And this man, there is T1 acting in this direction on the man's hand. So friction will be acting this way. So let's say the statements, what are they saying? The work done on humans by the tension force relative to earth is 0. Relative to earth, work done against T1 by human A. Okay. Relative to earth, work is done against T1 by human A. Relative to earth, work is done on human by T2. Right. So it looked like there was some problems with the statements. Let's get back to 17th. Now we'll do the other questions and finish it off. 18th one. Two masses, 6 kilogram and 4 kilogram, are attached to the end of smooth ropes that move over smooth, weightless pulley. So uh, ropes are smooth, weightless pulley, right? Okay. So the weightless and smooth pulley. Pulley is smooth. Which is the incorrect statement. Careful, they are talking about incorrect statement. So we have to find out which one is wrong. The force exerted on both sides of pulley by the ropes equal to T1 and T2. Force exerted on the both sides of pulley by the ropes. Yeah, correct. Here the pulley will be pulled down by T1. Here it will be T2. Okay. So if T1 and T2 are equal, moment created from either side is same. Therefore, pulley will not rotate. But if T1 and T2 are not equal, pulley can rotate. For that to happen, for T1 and T2 to be different, there must be friction. Okay, so this is correct. Force exerted on both sides of pulley by rope. So they have told it's smooth. So this is correct. Since it is smooth, tension will be same. We have studied in a people, tension will be same. And I think have they mentioned? Okay. Yeah. The acceleration of the masses is equal to the tangential acceleration of any point of the circumference of the pulley. Yeah, that's correct. Now, if this is moving down at the acceleration of A, this will also move down at acceleration of A. Right? Okay. The pulley will not rotate if frictional force between the pulley and rope is zero. Yeah. Because for pulley to rotate, guys, the tensions must be different. The tensions must be different for the pulley to rotate. If not, if T1 and T2 are equal, there is a clockwise movement and an anti-clockwise movement. Both are equal. So there is no resultant torque for the pulley to rotate. So it will not rotate if there is no friction. The tension forces on both sides T1 and T2 will be unequal if frictional force is present between the pulley and axis. This is what I'm talking about all this time. That's correct. If pulley is not smooth, we discuss about that even in what people parallelogram theorem and all. For tension to be equal throughout the string, pulley should be smooth. Yeah, right. The tension force on both sides T1 equal to T2 when there is no frictional force between the pulley and axis when the pulley has weight. What about this one? The tension force on both sides T equal to T1 equal to T2, sorry, T1 equal to T2 when there is no friction force between the pulley and axis and when the pulley has weight. When the pulley is not light, what will happen? The pulley is not light, will the tensions be equal? So the summary is, if there's a pulley in the system and when there is a rope or string going over the pulley, if you want the tensions on either side of the pulley to be equal, there are two conditions. One, the pulley must be smooth, it must be frictionless. Second one, the pulley must be light. Now, most of the past paper questions, wherever you take tensions to be equal, in the question they would have mentioned the pulley. They consider that the pulley is smooth and light. All right. So this is the answer for this question. Question number 19. As shown in the diagram on a rough horizontal surface, two blocks A and B of mass 20 kilogram and 5 kilogram respectively are placed in such a way that block B is above block A. In diagram X, a horizontal force of 125 Newton is exerted on block A, and in diagram Y, a horizontal force of 150 Newton is exerted on block A. Okay. In both, they are exerting the force on block A. The coefficient of frictional force between the block is between the blocks is 0.2, and that between the block A and surface is 0.5. So to clarify that, here mu is 0.5 and here mu is 0.2. And let's move on. Yeah, now they are asking for the correct surface. Sorry, the correct statement. Okay, they have given us 5 statements. We have to choose the correct statement, right? Let's analyze that. First of all, let's try to find out the limiting frictional force. So here you have here the perpendicular reaction acting on B, that is going to be balancing only the weight of B. So that will be equal to, I'll say RB. That will be equal to 50 Newton. And perpendicular reaction acting on A, that is going to be equal to how much? It has to balance both the weights of B and A. Therefore, it's going to be 250 Newton, right? So let's use this equation: limiting frictional force equal to mu R. And for A, when you apply this, FLA, that is equal to mu is 0.5 into 250. So what is the answer? 125 Newton, right? And B, FLB in the sense, yeah, B, okay, FLB, that is equal to 0.2 into how much? 50, isn't it? 0.2 into 50. So, what is the answer? 10 Newton, right? 10 Newton. All right, fine. Yep. Between the blocks is 0.2 and between the surface A and this is 0.5. Okay. Okay, right. Fine. So what will happen here, guys? What will happen here? What will happen here, tell you? In this diagram, they are applying a force of 125 to A. Will A move? Will A move? A is not going to move, right? A is not going to move because when A tries to move, the surface itself will give a 125 Newton force and stop it. It will be stopped. Okay, right. So B will not experience any, B doesn't have to stop A. B doesn't have to stop A, correct? Because the flow itself can stop A. So B will not experience anything, it will just lie on A. Therefore, in X, B will not experience any frictional force. So it should be 0, 0, right? So fourth and fifth are wrong because B doesn't have to experience any frictional force when it's yeah, when A is not moving, when A's motion is restricted only by the frictional force given by the flow. Right now, here, when 150 Newton is applied, what will happen to A now? A is going to move, right? So A will be experiencing a frictional force here, F1, and B will also try to stop A, F2. B will also try to stop A. F2 will be there, right? So now what will happen? In Y, frictional force on block B, what will be the answer, people? What will be the answer? When you apply 150 Newton, they both are going to accelerate now. No? They both are going to accelerate. And yeah, the system is going to accelerate. A will be experienced, and if you take A and B, on A, there will be three forces acting. One is at 150, and one is the frictional force given by B on A, and one is the frictional force given by the flow on A. And B will be experiencing a single force, and what is that? That is F2, because F2 is exerted by B on A. According to Newton's third law, A will be exerting equal and opposite force on B as well, F2. Right? So that F2 is the what? That F2 is the force acting on B now. So what do you think is the answer there? This is wrong. Third is definitely wrong. Third is definitely wrong. In Y, the frictional force on block B is dynamic frictional force. Dynamic friction. So if we will be move now, will be move. What do you think will happen to be? Is coefficient of friction. Now, if 150 Newton is exerted. Object A is definitely going to move because the maximum frictional force which can be given by the flow is 125. And the maximum frictional force which can be exerted by B is 10 Newton because FLA B is 10. So B will be experiencing a force of 10 Newton, like this, frictional force. And if you consider A, now if you take, if you apply F equal MA for A separately, you will be getting 150 minus 125 minus 10 equals to MA. M for A is 20 into acceleration of A. So that will give you, here you have 15 equals 20 AA. So acceleration of A will be 0.75 ms minus 2. And acceleration of, for if you applied for B, F equals ma, what is the resultant force acting on B? 10 Newton. And what is the mass of B? 20, isn't it? No, 5 into acceleration of B. So B will be accelerating at 2 ms minus 2 on top of A. So B is going to have a different acceleration compared to A. Therefore, B will be moving on top of A as well. Right. So how is this 5 possible? Mm, 25, 0, 225 can't be applied. So I think first one should be the answer. Because 5 Newton is not possible acting on B. First one should B will also be moving on A. So let's settle the first one. B will also be moving on A. If B is moving on A, then the friction acting on B is dynamic friction force. Because sometimes it's like this. Even you can try this. You can keep two objects stacked upon each other. If you give a smaller force to A, both will move together, right? Both will move together. So B is at rest on top of A. So it is experiencing static friction there. Okay, but when you move A fast, try moving A faster, then B will also move on top of it. So then this kind of situation. So I think first it would be the answer for that because B will be moving on A separate, right? So first question number 20, right? Let's see. Two sailing boats which have unequal masses travel equidistance from rest. Equidistance means same distance from rest. So M1 starting at rest, M2 starting at rest, both have now traveled equal distance, but they are of different masses. The forces exerted by air on the sailing boat are equal and constant. Right, same force is exerted. Which of the following is wrong? Right, so same force is exerted and the object has gone to a distance d. Okay. The kinetic energy of two sailing boats are equal. Do you agree with that, people? Probably not, no? Because now this will have a velocity v1, this will have a velocity v2. How do you find the velocities? How do you find the velocities? Okay, you can find the velocities like this. You can say work done by wind, that is equal to kinetic energy gained, correct? Kinetic energy gained. So what is the work done by wind? That is Fd. And what is the kinetic energy gained? Half mv square, if you write a common equation. All right. So velocity. Okay, kinetic energy. So what can you say about kinetic energy? Same work is done, isn't it? So same work is done means kinetic energy has to be. Oh, sorry, that's correct. That's correct. That should be correct. Sorry, I thought it was speed they're talking about. Speeds are different. Speeds will be different, but kinetic energies will be same because they are performing. They are applying same force to same distance. So if we do the same number of work done is same, therefore kinetic energies will be same. Sorry. The sailing boats have the sailing boats with high mass has high momentum. What do you say about that? What do you have to say about that? Momentum. Talking about momentum. Will they both have the same speed? No, they will not definitely have the same speed. Now that is where I was getting at. Now here, if you take this equation, I'll continue. V square is equal to 2fd over m, 2fd over m. Therefore, V is equal to square root of 2fd over m. Sorry. 2FD over M. Right. Okay. So now tell me what is going to be V1? V1 is going to be equal to square root of 2FD over M1. V2 is going to be equal to square root of 2FD over M2. That's it. I use this equation commonly for both the objects. For both, M is different. So V will be this. Now let's find out the momentum. Now we know momentum is equal to mv, and let's apply that for m1 first of all. For m1, what is the momentum now? Momentum is equal to m1 into v1. Now what is v1, people? m1 into v1 is this square root of 2fd over m1. 2fd over m1. Okay. So I can take this m1 inside the square root, that will become m1 square. So ultimately you will be getting square root of 2m1 fd. Hope you guys understood that. Okay, if you want me to explain it better, now we have 2fd m over m1. This m1 is there. I'll take that m1 inside the square root. So what will happen? It will become m1 square into fd over m. So ultimately you will get an equation square root of 2m1 fd. Right, that is the momentum of m1. And what is the momentum of m2? Without doing all those things, you can directly say, tell me now, what is it? Momentum of m2 is going to be equal to square root of 2m2 fd. 2m2 fd. Okay, so you look at the momentum. They depend only on m1 and m2 because 2fd are common for both the ships. No, people. 2 is anyway common. F is the same force. D is the same distance they travel. So if m1 is greater than m2, that means momentum will be greater than m1. And that's what the statement says, correct? Sailing ship with the highest momentum will have, sailing ship with the high mass will have high momentum, correct? So I have proven it to you mathematically. The acceleration of sailing boats with high mass is lesser than that of lesser weight boat. What do you say about that third statement? What about that third statement? That is easy to derive because third statement, I will do it here. The acceleration of the sailing boat with high mass is lesser than that of less weight boat. Okay. Now, if you for sailboat, if you apply F equal ma, people, okay, F equal ma, acceleration is equal to F over m. Acceleration is equal to F over m. Remember, F is constant, isn't it? F is constant for both the boats. They have told. Read the question carefully. The force exerted by air on the sailing boat are equal and constant. If F is constant, if mass increases, what will happen to acceleration? It will decrease. That's what statement 3 says. Read carefully. The acceleration of the sailing boat with high mass is lesser than that of lesser weight boat. Okay, so they are saying if the mass is high, acceleration is less. If the mass is less, acceleration is high. Good. Then the fourth one. The impulse made by air in lesser weight sailing boat is equal to that of higher weight boat. What about that then? Impulse. How do you decide impulse? The change in momentum, na? The change in momentum. Okay. What can we say about that? Fifth one is definitely correct. Work done by air on two sailing boats are equal. That is correct. Why is it correct, LW? Because we know work done, that is equal to force into distance. Force into distance. Read it carefully. The forces exerted by air on the sailing boat are equal. Okay. Travel equidistance. So both F and D are same for both the sailing boats. Therefore, work done is also equal. So 1, 2, 3, and 5 are definitely correct. Fourth is the question mark. Now let's go back to fourth. The impulse made by air in lesser weight sailing boat is equal to that of higher weight boat. What do you think about that? Impulse. Impulse means change in momentum. Change in momentum. Or that is incorrect. No, that is incorrect. You know why? Impulse means change in momentum. We just figured out the momentum. They are not same. No, both of them. The initial. What is the initial momentum? Tell me. Both of them. The initial momentum is 0 because they start from rest. And after some time, they have acquired momenta, but the momenta are different. Whoever has highest mass will have highest momentum. Now talking about impulse, we know force into time is equal to change in momentum. Now what is the change in momentum of this boat? It is m1v1 minus 0. Initial momentum is 0. What is the change in momentum of this one? That is m2v2 minus 0. So that is m2v2, and they are not equal. Change in momenta are not equal. Therefore, impulse are not equal. But fourth statement says the impulse made by lesser weight sailboat is equal to that of higher weight sailboat. This equal part is incorrect. So the answer is 4. All right. So it's a matter of just analyzing these people. Not that hard. Just focus on work done and energy. Question number 21. All right, question number 21. In the following diagrams, equal masses are hung on the ends of a uniform rod. Uniform rod means, yeah, that means the center of gravity is going to be exactly at the center. In which of the following equilibrium is possible? Which of the following equilibrium is possible? Is that what they're asking? Yeah, okay. But the problem is, people, this question is incorrect. Because I just checked the Tamil medium paper. It says, equilibrium is not possible. Okay, that's it. I was wondering because no, here it's possible. This one possible, this one possible. These things are possible, right? So there's only one diagram in which equilibrium is not possible. That is this one, both. Imagine you tilt the mass like this. What will happen? Here it will slip and fall down. But here it's not like that. The rope is it's hanging from the rope, hanging by the rope, so the rope can hold it. But here, if it slips, it will slip and fall down. This part, both. Okay. Now here, okay, here it's flat and it is rested on this knife edge. So if it is flat and rested on the knife edge, it will not slip. But when the string is available, string can hold it without toppling. String can hold it without toppling. Here, it's slightly slanted. Just a point is in contact. That's not good enough. Sometimes if it doesn't have enough friction, it will just slide and fall off. So fourth is the most vulnerable to losing its equilibrium. English medium paper, there's an error in translation, unfortunately. Okay, so should give you all marks for this. Question number 22. Figure A shows the reading while 3 legs and central screw of the spirometer are touching the glass surface. Okay, that means they are checking for the zero error. They are checking for the zero error. The first diagram, right? The readings taken while holding the 3 legs and the central screw on the concave mirror are shown in figure B. Okay. It should be substituted in this equation, which is used to find the radius of curvature of a concave surface, right? Fine. So we need to find out H. That means we need to find out the correct reading. Now this is the zero error, and this is the reading you take. So we have to make the necessary changes for zero error. Right, fine. So first of all, let's find out the zero error from this diagram. What is the zero error here, people? Careful. Zero error. Now zero error will be equal to it is above this. First of all, disk is above 0. If disk is above 0, whatever the circular scale coinciding, we can directly take that, and it is after 0. So 0, 1, 2, 3, 4, 5, right? It is after 0. So you can say what? First of all, least count. Let's try to find out least count. Least count is equal to pitch is going to be 1 millimeter. You see, 1 millimeter. Pitch is 1 millimeter. It's a pitch over number of circular scale divisions. Pitch over number of circular scale divisions. Can you say how many circular scale divisions are there? Pitch is 1 millimeter because the gap is given as 1 millimeter over circular scales. It's 60, 65, 70. So definitely 100. It can't be 50. So least count is definitely 0.01 millimeter. All right. So the zero error here is above 0, 20. So we can directly take 20, multiply that by 0.01. The answer is 0.20 millimeters. That is the zero error. And now here from figure B, you can find out the reading. Now reading is going to be, now you have to be a little careful. You can see the circular disc, it is below the main scale 0. It is below the main scale 0, and it has passed 1, 2, 3 units. It has passed 3 units. So the reading is 3 plus The coinciding unit is 60, but I can't take 60 directly because the disk of the spherometer is below 0. So it has to be total circular scale divisions minus coinciding division into least count. Okay, you can't directly take 60, yeah, because the disk is below 0. So the answer is 3 plus 0, 40 into 0.01, that is 3.40 millimeter. 3.40 millimeter. Okay. Now the question is, should we add the zero error or subtract the zero error? Should we add the zero error or subtract the zero error? What should we do? What should we do? Right now, we should add or subtract. We should definitely add, because when you started, the disk was above 0. When you started, the disk was above 0. And now after you take the second reading, disk is below 0. So we have to consider this whole length. So this small length must be added with this length. So you should add it. So the final reading, final correct reading is going to be how much? 0.20 plus 3.40. Hence the answer is 3.60 millimeters. Careful. Two things to be concerned about. Places where you might have gone wrong is this part. You might have forgotten to subtract it from 100, and then the other part, here you have to add the two answers you get, not subtract. Careful. So the answer for 22nd is third. Okay. Now question number 23. Not sure if that is there in the A-level syllabus. Finding the center of gravity when masses are given at different places like this. Now this is a coordinate system. This is a coordinate system. So you can see the points, the coordinates of points. Now this, what is the coordinate of this point? It is 3,2, correct? 3,2. And if you take this coordinate 1, 2, 3, 4, 5, 6, 6 is the x coordinate, 1, 2, 2 is the y coordinate, 6,2. And if you take this one, it is 1, 2, 3, 4, 5, 6. 6 is the x coordinate, and 1, 2, 3 downwards, minus 3 is the y coordinates. And here, 1, 2, 3 is the y coordinate, and 3 x coordinate means 3 comma minus 3, like this, likewise you have, right? There are 3 parts. Now the figure shows the distribution of 4 particles with mass 1 kilogram, 2 kilogram, 4 kilogram, and x kilogram. For having the center of gravity at point O, what should be the value of x? So the center of gravity is at O, settled. So if center of gravity is at O, people, this is how you find it. I mean, if you take the moment about x-axis components about O, the total must be 0. Now, for example, I hope you understood it. If you take moment about this point, but using the x-axis components, this is how you find the center of gravity. Now imagine, this is a little too much. Imagine there are 4 random masses like this: M1, M2, M3, and M4, like this. And this is the origin. This is the origin, in a Cartesian plane. This is the origin, 0, 0. This is x-axis. This is y-axis. So they all will have coordinates, people, x1, y1. This will have a coordinate x2, y2. And this will have a coordinate x3, y3. Sorry, yeah. And this will have a coordinate x4, y. And the center of gravity will be somewhere randomly here, right? The coordinates of that is x comma y. So if you want to find x, what you need to do is x is equal to sum of mixi divided by sum of mi. Now what is that? That is it. That is this. You have to multiply each mass by its coordinates. M1 x1 plus M2 x2 plus M3 x3 plus M4 x4, and you need to divide the whole thing by the total mass, that is M1 plus M2 plus M3 plus M4. That is how you find the x coordinate. And how will you find the y coordinate then? Y coordinate of the center of gravity, that will be sum of mi divided by sigma m. So this is m1 into y1 plus m2 into y2 plus m3 into y3 plus m4 into y4 divided by m1 plus m2 plus m3 plus m4. Now this was not taught to you obviously, and it's not there in the advanced level syllabus. So here what you need to do is, now this is the center of gravity. When you take moment about center of gravity, the resultant moment must be 0. So I have marked the coordinates. I will write down, see if you can understand. Huh? Right. Taking moment, I'll write it in a different color. Taking moment about O. When you take moment about O, the resultant must be 0. So this one is the only, we'll consider only the x-axis components. Huh? X-axis, x coordinates or x coordinates. These are the x coordinates. Right, let's start. This will be 1 into 6, correct? 1 into 6, mass into distance, 6. Plus, this is 4 into 6. 4 into 6. And actually, the x coordinates here are negative, sorry, yeah? -3, -3. Because from O, this is in the negative side. 1, 2, 3 in the negative side. So, -3. From O, 1, 2, 3 in the negative side, -3. Right. So, moment due to this one, it will be x into, the mass is x into the coordinates, that is -3. Plus, moment due to this one is 2 into coordinates is -3. And the whole thing, when you add everything, it should be 0. Right. So, this is 6 plus 24, that is 30 minus 3x. 30 minus 3x minus 6 equal to 0. 3x goes to the other side. Here we'll have 24. And the other side you will have 3x, and that will give you x is equal to 8 kilograms. So the answer is 8. That is how you have to find 8. Okay. If you use the other method now, yeah, if you use the other method, for example, now you can take this as 1 and 2, then that will be, you will not be able to exactly get it as 8. So this is the only method you can get 8 people. So I don't think this is in your scope. So we can ignore this question also. I just wanted to explain how that 8 came. This is the scheme answer also. Let's check the scheme answer. For 23rd, they have given the third answer. Yeah. Okay. So in model papers, in case in future, if you get questions like this, let's use this concept. Okay. Take moment about the center of gravity. So you can use take moment about, x axis component and y axis component also separate. And then it usually equal to 0, something like that. So here only one unknown was there. So I just took it taking x coordinates. If this was x and this was y gram, then you have to take two equations like this. One, you will use the x coordinates, and for the other one, you will use the y coordinates. How will it be? 1 into 2 minus 4 into 3 minus 2 into minus, like something like that. Like that, you can do it. Right? Fine. Don't think too much about it. I don't think this is there in your syllabus. Just additional information. The figure shows two masses A and B attached by a light inelastic thread. That means inelastic means total length will not change. Total length doesn't change. From the top of a slant surface of angle 30 degrees with the horizontal, two masses are released from rest along the slant surface and B free, A along the slant surface and B freely under gravity. So both A and B are falling. B is falling down, A is moving along the slant surface. If the length of the thread is 120 centimeter, the minimum time needed for the thread to become tight. Right. So let me draw this diagram again. From the side. So let's observe it from the side. That way it will be easier for us. I'll draw a bigger diagram. Right. The angle is 30. Right. So initially, B is here, A is here. Both are at rest initially, guys. Right. Then this is falling down to a certain distance. This will also fall down to a certain distance, like this. Okay. Who is A? This is A, and this is B. Remember, right? And now the total length. The total length. This is where how they will be after some time. This is time equal to 0. Wait, if this is confusing to you, I will draw this in broken lines because this is to indicate where they were initially. Okay, now this is where they are now. Okay, never mind. We don't have to indicate that. The diagram here gives you the idea. Now the string is completely extended. Completely extended. And remember, both would have traveled same time when that happens. That's very important. No? Both would have traveled same time. And now B has traveled a certain distance. You can see from its initial position. And A also has traveled a certain distance from its initial position. Let's take this as SB and it's as SA. All right. Can you tell me what is SB plus SA? What is SB plus SA? Now the string is fully extended. What is SB plus SA? That should be the total length of the thread. That is 120 centimeter. Now the thread is fully extended. So SB and SA, when you add them, it will be should be that, and that is 1.2 meters. So I need to get an equation for SB. I need to get an equation for SA. Substitute that here, and I will get it easy. For B, acceleration is gravitational acceleration, just G, easy. Okay, and that will be 10 ms minus 2 because it's moving, falling down free. But A is moving along the slant surface like this. And we have learned when something slides downwards along a slant surface, A is given by what? Now we have G like this. So the acceleration component of that along the inclined plane is going to be G sine 30. Okay, it's like mg sine 30 we take, people, when an object is like this, weight mg. And how do you take the component along the inclined plane? Mg sine 30. No? Similarly, G is downward. So the acceleration along the inclined plane has to be G sine 30. And that is 10 into G sine 30 is half. So that is 5 ms minus 2. B will be going down at 10 ms minus 2. A will be sliding along the inclined plane at 5 ms minus 2. Okay, done. Almost there. Let's apply S equal ut plus half at squared for both A and B separately. Okay, right. First of all, let's apply for B, and let's apply downwards because B is falling downwards. Displacement of B is SP. Initial velocity is 0 plus half into 10 into t square. T is what we are supposed to find out. So SB is equal to how much, people? 5t square. For A, I'm going to apply the equation along the inclined plane. S equal ut plus half at squared. Displacement of A is SA. Initial velocity is 0 plus half into. Now for acceleration, I should put 5. I should put 5. Why should I put 5? Because the acceleration along the inclined plane is 5 into t square. So I'm getting SA equals 2.5 t square. But we know SB plus SA is equal to 1.2 meters. I am going to use SI unit, right? So I can substitute here. 5t square plus 2.5 t square, that is equal to 1.2. 1.2. So 7.5 t squared is equal to 1.2. T squared is equal to 1.2 over 7.5. And that is 12 over 75. To make our lives easier, I'll simplify both by 3. That will give you t squared equals to what? If you simplify 12 by 3, it's 4. If you simplify 75 by 3, it's 25. So t is equal to square root of 4 over 25, and that is 2 over 5, and that is 0.4 seconds. Answer is second. Find the different accelerations, then find the displacements, add them and equate them to the total length of the thread. Because if A has moved this distance and if they have moved a total distance of 120 centimeters, that means the thread is fully extended. Okay, answer is second. For a 300-gram vessel, okay, a handle of mass 400 gram with a uniform cross-section area was attached. All right. If the vessel contains 600 gram of water, how much minimum amount of water should be removed from the vessel to collapse the equilibrium? Okay. Now you must have these pans at home. When you put a lot of water, it can stay like this. But when you remove water, what will happen? This will topple like this, no? It will topple like this. This part will just topple like this. It will topple like that when you don't have enough water inside. So when you don't have enough water inside, it's going to topple like this. We don't want that to happen, right? So we are going to see at which exact moment it's trying to do that, right? So at the verge of toppling or at the verge of at the verge of the collapsing of equilibrium. What will happen, people? At the verge of the collapsing of equilibrium, right? Let's see what's going to happen. You will have a system like this. I'll quickly draw it. One, then two. Right. So we need to get rid of the upper part. Yes. When this thing is about to collapse, very good. I got an answer from someone. There will be some amount of water. Now we have removed water. We don't know now how much water we have. We have to find how much of water is there. If I know how much water is there when it's about to collapse, initially I know how much water was there, 600, isn't it? If I subtract this amount of water from that, then I have the answer. So when it is about to collapse, people, the R value has to be what? 0. Perpendicular reaction has to be 0. Good. Why does it have to be 0? Because if it's going to collapse, the contact between the bottom part of the surface and the flow should be removed. Then only it will fall. It will go up and this will go down. Right? So R should be 0. And then the forces. We are going to take moment about this point because that is the center point, X. How many forces are acting here? 2 forces will be acting downwards here. What are they? 2 forces. One is the weight of the vessel. I'll put weight of V plus weight of water. Okay, well, vessel has a mass, yeah, see, 300-gram vessel. So weight of vessel plus weight of water. That's what I have put here. And here we will have weight of the handle, And what will be this distance now? It is 10 centimeter. This distance will be now 5 centimeters. And this distance will be half of that. That will be, now this is going to be 5 centimeters. And this is going to be 10 centimeters. Right. Now we are going to find out how much water is going to be here. Okay, guys. So let's take moment. Clockwise moment about X is equal to anti-clockwise moment about X. What is a clockwise moment? These two forces, weight of vessel plus weight of water, must be multiplied by the perpendicular distance, that is 5, equal to, on the anti-clockwise direction, weight of the handle into the, what do you call that, the perpendicular distance, that is 10. Now I have put 5 and 10 without changing centimeter to meter. There's no point in table. 5 should be divided by 100, 10 also should be divided by 100. So what is the weight of the vessel? Weight of the vessel is, mass of the vessel is 0.3 kilogram into 10. Hope you understood that. Plus weight of water, we don't know now. I'll take the mass of water here as MW. So mass of water into 10. Whole thing into 5. Sorry. Whole thing into 5. Just that 5 is there. Equal to weight of the handle. Mass of the handle is 400 grams. That is 0.4 kilograms. This is 0.3 kilogram. That's 0.4 and 0.3 only coming here. 0.4 kilogram into the center, gravitational acceleration to get the weight into 10. Okay, so I didn't have to put that 10. It's going to get cancelled off anyway. See? All right. So let's simplify this and find how much, what is the mass of water in the vessel now. So here we have 1.5 plus 5 m. No. I think we can simplify this 5 also, no, people, without wasting time. Let's do that. I can simplify this 5 and this 10 and put a 2 here. Therefore, final answer. Here I will have 0.3 plus MW. On the right side, it is 0.4 into 2, that is 0.8. Okay, so MW is equal to 0.8 minus 0.3, that is 0.5 kilogram. So MW is equal to 500 grams. 500 grams of water is remaining in this vessel. So, what is the mass of water removed? Mass of water removed is how much? Mass of water removed is going to be, initially we had 600 grams. So 600 minus 500, that was 100 grams. Right. So the answer for this question is going to be first one. Because they're asking for the mass of water removed. Right. Maybe you have not come across questions like this. It's quite understandable because still you are in term 1. Get used to these things, practice. Okay.